Good day everyone. On this video I'm trying to explain the basics of trigonometry, and this is on the level 3 NCV level 3 for TVET students. Okay, here I've drawn a Cartesian plane with a circle of radius r. Don't mind this negative here. This is just to show that this side is in the negative side of x-axis and this side is in the negative of the y-axis, but the length of the radius is still r. Like from 0 up until here, it's r units. Even from here to the side, it's r units. It's a distance, remember, it can't be a negative. Now I want to show you something. If I pick out any point on the circle, suppose there's a point here, and then I labeled it with coordinates, x coordinate and y coordinate, right? Remember, every point on a Cartesian plane has x coordinate and the y coordinate. If I draw a straight line from the origin to that point, remember a circle has equal radii all over. So from here to here it's r, radius r, right? Then the vertical side, the vertical length there is y, because from here up until to this point is this y value. So the distance is y. From here to here should be x, right? So this is a 90 degree. So we have a right angle triangle. So what do you remember about the right angle triangle? We know that if you sum up the squares of the sides, the x squared plus this y squared, it should give you the hypotenuse. The hypotenuse is this r length because it's opposite to the 90 degree angle. So this should give you r squared. This is according to the theorem of Pythagoras, right? This is the theorem of Pythagoras. Fine. Now what I'm gonna show you here, this is the basic formula. In fact, this is even an equation of a circle. You'll learn this later on. I don't know, but in level 4 you don't do this, but in grade 12 you do this. In grade 12 you'll meet this equation. This is the equation of a circle with the center at the origin. This is an equation of a circle with the origin as a center, right? But I'm not going to touch much about the circle geometry or analytic geometry of circles. I'm not going to do so. So now what I'm going to do here is check. Now I want to show you guys something. Remember, in trigonometry you have learned somewhere when you introduce trigonometry that sine of an angle, if I call this angle here theta, sine theta is always opposite over hypotenuse, right? And cos of theta is adjacent side over the hypotenuse. Now what is the opposite side here? The opposite side, which is opposite to the angle theta, is y. So sine theta is y over hypotenuse is r. Cos of theta is adjacent over hypotenuse, but your adjacent side here is x over r, right? Your tan theta is always opposite over adjacent. So it's what? Opposite is y, adjacent is x. So now I'm not gonna do the reciprocals of this. I'm just gonna focus on this 3 only. Now remember this, in trigonometry, when you measuring your angle, you starting from your positive x-axis and then you move anti-clockwise. So here it's going to be 0 degrees. As you move up until here it's 90 degrees, and then you move to the side, here it's 180 degrees, right? And then this side you reach 270, and then coming back to 0, you have completed a revolution, 360 there, right? So now remember the cast rule. What does it say? I'm just gonna write it here. Cast rule. In your fourth quadrant we write C, in your first quadrant A, in your second it's S, and then in your third quadrant it's T. So this A means all are positive, the side, right? All. When I say all, I mean the sine and the cosine and the tan are all positive, right? Here, only sine is positive. So sine is positive, right? This side, in other words, when I say only sine is positive, it means your cosine is negative here, even your tangent is negative here. So this side, the T stands for tan being positive. This side, the cosine is positive, right? Remember this is all cast rule. This is cast rule. So cast saying in your first quadrant, I'm just gonna write first Q. So in your first quadrant, all are positive, right? Meaning when I say all, I mean your sine, cosine, and tangent. And then second quadrant, only sine is positive. Sine is positive. I was supposed to write only here. Only sine is positive. In your third quadrant, only tan, which is tangent, is positive, right? In your fourth quadrant, only cosine is positive, right? This is true about this thing, yeah. Now, this is just an introduction to trig ratios on a Cartesian plane, right? So now, remember this. You'll need this kind of knowledge to solve problems, basic problems in trigonometry.